Alright, so we want to look at this AP free response question from 2000, and it was question number 2. Usually question number 1 and 2, always question number 1 and 2 are calculator questions, but we don't need a calculator here at all. So two runners, A and B, run a straight track, so you can read all that, graph. So as you read the question, you may want to take notes or underline or highlight certain things in the question so that you can find them quickly as you move back. So meters per second, and then here we can see it says indicate units of measure, so that's something I've pointed out before. That means they're going to give points for that. That means you absolutely want to make sure you keep track of that. Alright, so they gave us a graph of velocity. They give us a lot of graphs, and we need to figure out what those graphs tell us. And so that's the graph is for runner A, and they give us an equation of velocity for runner B. So the first thing says find the velocity of runner A and the velocity of runner B at 2 seconds. So A, I'm going to find the velocity of runner A at 2. So I'm going to say the velocity of runner A at 2. So this is the graph of velocity, it says, so I should be able to get the velocity off of the graph here. Now, hopefully you are not just sitting there approximating this value over here, because that's not going to be good enough. We need to get an exact value, and we have a line segment here. So we can find the equation of this line segment and then plug in 2 and calculate the exact value there. So hopefully you can pause and think about what that would be. So I'll say y of A equals, and so if you think about these 2 points here, maybe pause the video, see if you can come up with the equation. So it's going to be the change in y over the change in x. So the change in y is 10, the change in x is 3, the scales are not the same. So the slope is 10/3, and the y-intercept is 0. So there's an equation for that. So now we can plug in 2, because that's what the question asked for. And that's going to be 20 over 3. So it's going to be 20 over 3 meters per second. Alright. And that's it for that one. And for the second part of that equation, we want the velocity of runner B at 2. So we're just going to plug 2 into that equation. So that would be 24 times 2. And what is that? 2 times 2 plus 3. And that's also going to be meters per second. Now on the AP exam, if this is a real AP question, I would stop right there. That would be it. That's what you should do. Because if you make a little silly mistake in here, you're going to get no points for this question, 0. If you leave it like that, you'll be okay. Now in class, we're going to keep going, because if it's a multiple choice question, we do have to continue. So, because the multiple choice won't look like that. So we need to keep going here, and that would be 48 over 7 meters per second. Alright. Now, that's part A, and that was an actual free response AP question. Probably 1 point for each of those. The units point would be combined, so you would have to have the units correct here and here. So let's move to part B, and part B says find the acceleration of runner A. So if we think about it, the acceleration is the derivative of velocity. So the acceleration is equal to the derivative of velocity. Now this is an important concept, so we have to think about the derivative of a graph. So the derivative of this graph is talking about the slope of the tangent line. So we just said that here, the derivative of a graph is the slope. So that's pretty nice. We're just asking for the acceleration of a at 2, and we're just looking at the slope of that line, which we already calculated in this formula. So that's going to be 10/3 meters per second squared. Every once in a while, a kid will put feet or hours. Like, you have to be very careful about identifying the proper units. You don't want to lose the point because you put feet per second or something strange like that. Okay, and then we want the acceleration of runner B at 2. Now, when we have an equation and we want to find the derivative, we need to take the derivative using the rules, and that's the quotient rule. So that's going to be low d high minus high d low. D low is going to be 2 over low squared. And we're going to evaluate that 2. So I don't need to simplify the algebra there. What I should do is just plug in 2 for t now and change it to arithmetic instead of algebra. So plugging a 2 in here now, and again on a actual AP test we would not want to be doing all the work anyway, so we're going to plug in 2, but you don't want to get too cute, so maybe do a little bit of arithmetic here. So 2 times 2 is 4 plus 3 is 7, so I'll go that far, because if you're not doing anything then you might write it down incorrectly or not have the right parenthesis or something like that, and then we're going to lose that. So, and then minus, and over here maybe I'm plugging in 2 for t, so 2 times 2 is 4, so maybe I'll leave that as 4 times 24. So I'm doing a little bit there, and then again here this is going to be 7 squared. Don't forget the units, because sometimes it's awkward, you're leaving it like that, so it's going to be meters per second squared. So that would probably be 4 points, 1 for each of those, and then 1 point for all of these units, but you would have to have all of those units. So if you forgot to put the units on this one, you would lose that units point. Those of you who had me for honors geometry, was something similar to that with like degrees or units on the test. If you didn't have units on the page, I would take a point off. If you didn't have degrees, I would take a point off. So this is going to be the same thing here. I'll take that point off. Now, we could actually finish this, but just, again, if it was a multiple choice question, we would need to keep going. So if you notice here, we could factor out a 24. That would be 3, so you'd have 3 times 24, which is, maybe I'll write that down here, 24 times 3 over 49. So that's going to be 72 over 49, and that doesn't reduce. Okay. So I added this question. There's usually 3 or 4 parts to each question, so I took them off here because they were from a different chapter. But I did add another part of my own. So I'm asking you, what's the acceleration of runner A at 5? So we go back to the graph, and we look at 5, and we would be up here. And so we want to look at the slope of this line. Well, the slope of that line is 0. So the acceleration of runner A at 5 would be 0. So I added that for a reason. I must have saw that on an AP test or in some of their preparation materials. So I added that. That was not something that was in my old notes. So I try to improve my notes as I go. Okay, last question. And this is from the 2008 multiple choice section, number 82. That means it was a calculator question. So if you have your calculator handy, you can get that out. I'm going to talk about it. I don't know if I'll show the calculator or not, but we'll see. Okay, so again we have a velocity equation. So here's velocity, time greater than 0. So you want to pay attention to those restrictions when they tell us stuff like that. Don't go beyond that. So you don't want to give negative values because the time has to be greater than 0. What is the acceleration of the particle at t equals 3? So what I like to do on calculator question is I would probably put that into y1. So I would type that into y1, Actually, I'll just write that right here, y1. And I would type that in the calculator. Now, what I can do is I want to calculate the velocity at 3. So all I'm going to do is type this in the calculator. The calculator is pretty much going to do the work for us. So we want the derivative of the velocity at 3. So here's how we're going to do that. We're going to take the derivative. Now there's two main ways that you could do that. Actually, I just thought of a third, but the main way is that there's a little blue D above the 8. So above the number 8, over here on the left, there's a little D. So that stands for the derivative. So you'd hit second 8, and that'll give you the derivative. You could also go, there's a calculus menu. So when you're in the home screen, you can hit F3. And the very first choice is derivative, and it puts a parenthesis there for you as well. So in the home screen, F3 gives you the calculus menu, and it's the number one choice is derivative, differentiate. Okay, and so we're going to differentiate. We type that into y1, so you're actually going to type y1, and you need to put of x, so you need to put parentheses x. Or you could type this in right there. So this is on the home screen. This is what we're typing. So then we have to put comma x. A lot of students forget to put comma x. So you want to make sure that you put that in there, because we can take the derivative with respect to different variables. Alright, then you're going to put this line here, which is such that, and that has its own button, that is below the equal sign. And then you're going to tell it x equals 3. And that will give you the answer. So when the answer comes out, that's going to be here. Okay. Now, I just mentioned that students leave this off sometimes, so that's an error message. And the error message would be too few arguments. What that means is that you're missing the comma x. You're missing this part when you get that error message. Now you're going to get some other error messages sometimes. That's why it's important to practice on your calculator. So one of the things you can do if you get an error message is you can type F6, which is the second F1. You'll see a little F6 up there, and that's what I'm saying here. And then the second one down is new problem. So you hit number 2 or arrow down and hit enter, and on your home screen it'll say new problem. You hit enter, and that kind of clears out stuff that you've been using and it might be causing a problem. If that doesn't work, then you can also go down and hit second and the number 6, and above that in blue you see it says MEM for memory, and you can try to reset the memory, and that will fix some issues also. So if you want to see that on the calculator, I can show you what that looks like real quickly if you're already good. The other thing I was going to say here before I show you on the calculator, for those of you who see it, is memorize your trig derivatives. Okay, and so normally I would write those down right now and go over them again, but these videos are getting kind of long, so get out a piece of paper and see if you can write down all 6 trig derivatives. If you cannot, then keep doing it until you can. Okay, so turn our calculator on, and let me see here. And I said I would go to y equals, and I'm going to clear those out, and we're going to type in 7 minus parenthesis 1.01 parenthesis raised to the negative. So the negative is down on the bottom. It's not the subtraction. You have to use next to the decimal. To the negative x squared. And so when you type something in your calculator, you want to make sure that you look and see, is that basically the same thing? We can use x instead of t. That's not a problem. I don't know if using t right there, I'm not sure what that does. I've never tried that. But all right, so we've got that in there. You want to make sure you hit enter and go down the next line. Then go to the home screen. Like I said, you could hit the second button and the number 8. I guess I could be showing you more of those. So if I hit the second button and the number 8 here, you see a little D there, so that put the derivative there. Now I was telling you about this F3 menu up here. That's the calculus menu. That gives you some choices there. So I'm going to escape out of there because I already put the derivative. Now I'm going to use Y. I just type the letter Y, and then I just type the letter 1. That's Y1. Then parentheses X, comma X, close. So if I do that, it would just take the derivative of that. It'll give us something a little bit messy because we haven't worked with stuff like that before. That's in Chapter 5, exponentials. And then the such that button is right here underneath the E. And then X equals 3. And there you go, 0.055. And that's because under mode, we should be under fixed 3 right there. Third one down, arrow over, you should be on fixed 3. That'll always round it to the thousandths place for you. We only want to use that rounding in the final answer. So if I was using this to do something else, then I would store it alpha A. I would store that in A, and then I would use A when I needed it. So I think that pretty much covers what we need on this page. If you have any questions, anytime you're taking notes, if you have a question, maybe highlight it in a different color, green or pink or something. Pick a color for questions. Highlight and then ask those in the class sessions.